All right, we're going to start by expanding a function into a Taylor series. So if I have a function, I can expand it to f of a, f prime of a, x minus a, f double prime of a, divided by 2 factorial, x minus a squared. So you see a little bit of a pattern. I'll show you a proof of this in a minute. Let's look at this. So I've got second derivative, second factorial, second power. Third derivative, third factorial, 3 factorial, third power. And this can be summarized in writing it like this. So mostly I'm just going to want you to write out the first few terms, maybe the first 4 terms, establish the pattern, and then we'll figure out how to write it like this. All right, so what do you want to do first? You want to make a list of derivatives. So I'm going to encourage you to just even write the function down again, and then make your list of derivatives. You know this is chain rule. So when you're establishing a pattern, it's actually better not to multiply the numbers out. So I'm just going to leave it as 2 cubed. And then when I get to the 4th derivative, remember it's a little 4 in parentheses, 2 to the 4th e to the 2x. Okay, so there's my list of derivatives. Then I'm going to take the time to write out the list of derivatives evaluated at a. So in the next column, I'm going to say f of a, or f of 1, is e squared. F prime of 1 will be 2 times e squared. Double prime of 1, 2 squared e squared. So you're seeing the pattern, 2 cubed e squared. 4th derivative at 1, 2 to the 4th e squared. Okay, so now I'm going to put it into this pattern. So f of x equals, so first is f of a. So f of a is this, so I have e squared plus. So now I'm going to put this term together. So f prime of a, 2e squared, x minus 1, which that's a, divided by 1 factorial, plus second derivative at a, so 2 squared e squared, x minus 1 squared over a 2 factorial, plus 2 cubed e squared, x minus 1 cubed, sorry, it's messy 3 there, over a 3 factorial. And I'll just do the last one, 2 to the 4th e squared, x minus 1 to the 4th power over 4 factorial. Keeps going on forever. So what I'm going to encourage you to do now is to summarize and make this kind of a sum. So this sum is going to start at 0, and so when I plug in 0, I want this term to be generated. When I plug in 1, I want that term, n equal 2, n equal 3, n equal 4. The 0 term is not that useful to look at, so let's look at this term here. So looks like I've got 1, 2, 3, 4 things going on, and I just get to pick which one at a time I want to use, right? So if I go for this 2, looks like it's going to be 2 to the nth power, so that when n is 4, I get 2 to the 4th. E squared looks like it's there in every single term, so I'm just going to use e squared. Then I have x minus 1 all to the nth power, because when n is 4, I have this. When n is 3, I have this. N is 2 here. And then that's all over n factorial. Remember, 0 factorial is equal to 1. So that works for this term. So there it is. So this is the Taylor series, right? Series means infinite sum for this function at this value of a.
According to Wikipedia,